In this video, we're going to work on a few problems associated with Rolle's theorem and the mean value theorem. So let's review Rolle's theorem first. Rolle's theorem states that f must be continuous on a closed interval a to b. And also, the function must be differentiable on the open interval ab. In addition, f of a must equal f of b. So if these three conditions are met, then there's going to be a number c in the open interval a to b such that f prime of c is equal to 0. So let's think about what this means. So let's say if we have a graph that looks like this. And let's say this is A and this is B. So notice that the y value of A is the same as the y value of B. So if f of A is equal to f of B, then there is some number c where the slope of the tangent line is equal to 0, which is at this point. F prime of c is equal to 0. And that makes sense. So let's say if we have another shape, for example, let's say if we have a curve that looks like this. And let's say this is point A and this is point B. So f of A is equal to f of B. And let's say this is a closed interval. So we can see these two have the same y value. Then somewhere in between those 2 points, there's some number c where the slope of the tangent line is horizontal. It's equal to 0. So thus f prime of c is 0 at this local minimum value. So that's the main idea behind Rolle's theorem. Now how can we apply this information to a problem? Now let's say that f of x is equal to x squared minus 3x plus 2 on the closed interval 0, 3. Verify that the function satisfies the conditions of Rolle's theorem on a given interval, and then find all numbers c that satisfy the conclusion of Rolle's theorem. So we have a polynomial function, and polynomial functions are usually continuous. There's no restrictions on the domain. So there's no points of discontinuity. The things that you have to worry about are fractions, because you can't have a 0 in the denominator. You have to watch out for square root functions, because it can't be negative inside an even or a square root function with an even index number. And watch out for natural log functions, because you cannot have a 0 or a negative number inside a log or natural log function. So for a polynomial function, it's going to be continuous on the closed interval 0, 3, and it's also differentiable on the open interval 0 to 3. Differentiability means that the derivative is continuous. Now, the next thing that we need to find out is f of a equivalent to f of b? Are these two equal to each other? That is, f of 3, does it equal f of 0? Or f of 0, does it equal f of 3? A is 0, b is 3. So let's see if these two are equivalent. If they are, then we can find the c value. So f of 0 is going to be 0 squared minus 3 times 0 plus 2, which the whole thing is equal to 2. Now what about f of 3? 3 squared minus 3 times 3 plus 2. 3 squared is 9. 3 times 3 is 9 plus 2. 9 minus 9 is 0, so they cancel, and it equals 2. So f of a is equal to f of b. Therefore, the third condition has been met. So what that means is that there is some value c where f prime of c is equal to 0. So at this point, to find the c value, your first step is to find the first derivative of the function. So f prime of x is equal to 2x minus 3. So therefore, f prime of c, if we replace x with c, that is equal to 2 times c minus 3. Now we want to find the c value when the derivative is 0. So let's set it equal to 0 and let's solve for c. So if we add 3 to both sides, 2c is equal to 3. And then if we divide both sides by 2, c is equal to 3 over 2. Now you have to make sure that this number is within the interval. 3 over 2 is 1.5, and 1.5 is between 0 and 3. So this is the answer. Now what about this one? Let's say that f of x is equal to x divided by x minus 3 on the closed interval 1 to 5. So, does Rolle's theorem apply in this situation? Is the function continuous on the closed interval 1 to 5? The answer is no. If you set the denominator to 0, x cannot equal 3. So we have a point of discontinuity, or rather an infinite discontinuity, a vertical asymptote at 3, which means that the function is not continuous on the closed interval. So Rolle's theorem does not apply. Now what about this one? Let's say if f of x is equal to 2x cubed plus 3x squared minus 36x minus 54 on the closed interval negative 3 over 2. Okay, I might need more space for this one. To 3 root 2. So is the function continuous in this closed interval? Since we have a polynomial function, there's no points of discontinuity, so it's going to be continuous. And it's also differentiable on the open interval. So now we just have to see if f of a is equal to f of b. So what's f of negative 3 over 2, which is negative 1.5? Go ahead and plug it into the equation. Now for those of you who can't use a calculator, let's do this step by step. So it's 2 times negative 3 over 2 squared, cube, plus 3 times negative 3 over 2 squared minus 36 times negative 3 over 2 minus 54. So 3 to the third power, that's 27, but it's going to be negative 27. 2 to the third is 8, and 8 divided by 2 is 4. 3 squared is 9 times 3, that's another 27, and 2 squared is 4. So these two cancel out, which is good. 36 divided by 2 is 18, and 18 times 3, that's positive 54. The two negative signs cancel, and then we have a minus 54. So therefore we could say that f of negative 3 over 2 is 0, since everything cancels. Now let's evaluate f of 3 root 2. So it's 2 times 3 root 2 cubed plus 3 times 3 square root 2 squared minus 36 times 3 root 2 minus 54. So 3 to the third power is 27, and the square root of 2 raised to the third power, that's basically square root 2 times root 2 times root 2. The square root 2 times square root 2 is square root 4, which is 2. So it turns out to be 2 root 2. Three squared is 9, and radical 2 squared is simply 2. 36 times 3, 30 times 3 is 90, 6 times 3 is 18, so that's 108. So it's going to be 108 root 2, and then minus 54. 2 times 27 is 54, times another 2, that's 108. So this is 108 square root 2. 3 times 9, that's 27, times 2, that's positive 54. And so we could see that it's going to equal 0. 54 and negative 54, they cancel, and these two cancel. So therefore, f of 3 root 2 is equal to 0, so f of a is equal to f of b. So all three conditions of Rolle's theorem are satisfied. Since all three conditions were met, f prime of c is equal to 0. So let's find the value of c. So first, let's find the derivative. The derivative of 2x cubed is 6x squared, and the derivative of 3x squared is 6x, and negative 36x will become negative 36, and the derivative of a constant is 0. So let's set it equal to 0. So f prime of c is equal to 6c squared plus 6c minus 36. So let's factor the GCF. If we take out 6, what we're going to have left over is c squared plus c minus 6. Now what two numbers multiply to negative 6 but add to the middle term of 1? This is going to be positive 3 and negative 2. 3 times negative 2 is negative 6, but 3 plus negative 2 adds up to 1. So to factor the expression c squared plus c minus 6, it's going to be c plus 3 and c minus 2. So therefore, c is equal to negative 3 and c is equal to 2. So we have two c values in this particular problem. Which one is the right answer? Because f prime of negative 3 equals 0 and f prime of 2 is equal to 0. So we need to see which c value is in the interval. Negative 3 over 2 is about negative 1.5. The square root of 2 is 1.4. So 3 times 1.4, that's about 4.2. It might be a little bit more than 4.2, but it's around there. So we can see that negative 3 is not in the interval. However, 2 is. So this is the answer. C is 2. It has to be in the closed interval. Let's try one more example using Rolle's theorem. So let's say that f of x is equal to x times the square root of 4 minus x on the closed interval 0 to 4. So is the function continuous on the closed interval? If you were to graph the square root of 4 minus x, there are restrictions on the graph. It's going to shift 4 units to the right, but because of the negative sign in front of x, it's not going to open towards the right as a typical square root function. It's reflected over the y-axis, so it's going to go in this direction, which means x can be anything less than 4, but nothing greater than 4. For example, if you plug in 2, 4 minus 2 is a positive number, so that works. But if you plug in 5, 4 minus 5 is a negative number, and the square root of a negative number is not a real number, it's an imaginary number. So therefore, the domain of the function is everything from negative infinity to positive 4, but it includes positive 4. And it's continuous on this restricted domain. So we could say that the function is continuous on the closed interval 0 to 4. Now, is it differentiable on the closed interval? or on the open interval. The only way to tell is to find the first derivative, but let's do that later, since we'll have to find the c value, if it's differentiable. Now, f of a, does it equal f of b? So what is f of 0? This is going to be 0 times the square root of 4 minus 0, which 0 times anything is 0. Now what about f of 4? This is going to be 4 times the square root of 4 minus 4. 4 minus 4 is 0. The square root of 0 is 0. So the whole thing is 0. Therefore, f of a equals f of b. So if it's differentiable on the open interval, then there's some value c where the derivative is equal to 0, meaning the function has a horizontal tangent line at c. Now let's find the first derivative. To do so, we need to use the product rule. If you differentiate f times g, it's going to be f prime g plus f g prime. So if f is x, and if g is 4 minus x raised to the 1/2, then f prime is the derivative of x, which is 1, and g is just going to be 4 minus x raised to the 1/2, plus f, which is x, and g prime is going to be 1/2, keep the inside the same, 4 minus x, and then subtract the exponent by 1. 1/2 minus 1 is 1 over 2 minus 2 over 2, which is negative 1/2. After that, you need to take the derivative of the inside function according to the chain rule. The derivative of 4 is 0, but the derivative of negative x is negative 1. So that's the derivative of the function using the product rule, but we need to fix it up, so to speak, because in this form it's going to be hard to work with. So what we have is the square root of 4 minus x, and then minus, there's a negative sign, so minus x divided by 2 times the square root of 4 minus x. Since we have a negative exponent, we need to bring it back to the bottom. So it's going to be 4 minus x raised to the 1/2, which is simply the square root of 4 minus x. The 2 is already on the bottom, so it stayed there. The only thing that was on top is the x variable. So now we still need to simplify the derivative even more. So what you want to do, if you have two terms, you want to combine it into a single term by getting common denominators. So let's multiply the first fraction, or the first term, by root 4 minus x. Actually, by 2 root 4 minus x, top and bottom. So these two, the square root of 4 minus x times the square root of 4 minus x, is simply 4 minus x. Now that we have the same denominator, we can combine the numerators of the two fractions. So 2 times 4 is 8 if we distribute the 2. 2 times negative x is negative 2x minus x, that's a negative 3x. So this is the first derivative in its simplified form. Now earlier we said that the function was continuous on the open interval, or on the closed interval 0 to 4. Now, is it differentiable everywhere? Notice that we have a point of discontinuity in the derivative function. X cannot equal 4. If we plug in 4 into the derivative function, it's going to be undefined. We're going to have a 0 in the denominator. So does this disqualify Rolle's theorem? Now Rolle's theorem states that the function must be differentiable on the open interval a to b. So that is from 0 to 4, but it doesn't include 4. So 3.99 is included, but not 4. And you can plug in 3.99 in for x. 4 minus 3.99, that's 0.01. That's completely okay. So it's differentiable on the open interval from 0 to 4, but not on the closed interval from 0 to 4. So Rolle's theorem still applies here. So now let's calculate the c value. So we need to set the derivative equal to 0. When the numerator is equal to 0, the entire fraction is equal to 0. So we just got to set the top part equal to 0. If you're not sure why that works, see it this way. If you multiply both sides of the equation by 2 radical 4 minus x, on the left side, these will cancel. And so you'll get 8 minus 3x. On the right side, 0 times anything is 0. So it's going to be 8 minus 3x equal to 0. So therefore, you could just simply set the numerator equal to 0. So let's subtract both sides by 8. Negative 8 is equal to negative 3x. And if we divide by negative 3, x is 8 over 3. 8 over 3 is about 2.67, which is in the interval. So therefore, c is equal to 8 over 3. This is the answer. Now let's analyze the function graphically. If we graph it, it's going to look something like this. F of 0 is 0 and f of 4 is 0. The function increases and then it decreases, and it stops at 4 because the domain is restricted. So notice that f of a is equal to f of b. So therefore, there is a c value where f prime of c is equal to 0. So at c, the slope of the tangent line is equal to 0. And that's the main idea behind Rolle's theorem. Now let's review the conditions of the mean value theorem. So the function f has to be continuous on the closed interval a to b. And it has to be differentiable on the open interval a to b. If these two conditions are met, then f prime of c is equal to f of b minus f of a divided by b minus a. F prime of c is the slope of the tangent line. F of b minus f of a over b minus a is basically the slope between 2 points, which is the slope of the secant line. Typically, when you find a slope, it's the change in y divided by the change in x, which is equivalent to this expression. So the mean value basically states that there is some value c where the slope of the tangent line is equal to the slope of the secant line. Now let's analyze it graphically. So consider this function. Let's say this is point A and point B. The secant line is a line that touches the curve at 2 points. The tangent line is a line that touches the curve at a single point. So there is some value c where these two lines are parallel to each other. So at some point c, the slope of the tangent line is equal to the slope of the secant line. And the mean value theorem helps you to find that c value. Now let's try this problem. So let's say if f of x is equal to x squared plus 4x plus 5 on the closed interval 0 to 4. So find all numbers c that satisfy the conclusion of the mean value theorem. So, since we have a polynomial function, particularly a quadratic function, we know it's continuous on the closed interval, and it's also differentiable on the open interval. So now we can just use this equation. F prime of c is equal to f of b minus f of a divided by b minus a. So on the left side, we need to differentiate the function. We need to find f prime of x. The derivative of x squared plus 4x plus 5 is 2x plus 4. F of b, that's going to be f of 4 minus f of a, that's f of 0. The first one is a, the second one is b, divided by 4 minus 0. So let's multiply both sides by 4 to get rid of the fraction. So 2x plus 4 times 4 is 8x plus 16. Now what is f of 4? So let's plug in 4 into this equation. So it's going to be 4 squared plus 4 times 4 plus 5. And then f of 0 is 0 squared plus 0 times 4 plus 5, which is simply 5. So these two cancel. Let's move this up. 4 squared is 16, and 4 times 4 is also 16. If we subtract both sides by 16, these two will cancel. So we can see that 8x is equal to 16, and if we divide by 8, x is 2. So this is the c value. So c is equal to 2, and 2 is within the interval. It's between 0 and 4. So at c equals 2, the slope of the tangent line is equal to the slope of the secant line. And you can prove it if you want to. So we know that the derivative is 2x squared plus 4. To find the slope of the tangent line, plug in 2. So it's 2 times 2 plus 4. 2 times 2 is 4 plus 4. So the slope of the tangent line is 8. To find the slope of the secant line is the change in y divided by the change in x. So f of 4, that's 4 squared plus 4 times 4 plus 5. F of 0 is 5. 4 squared is 16. 4 times 4 is 16. 32 divided by 4 is 8. So as you can see, the slope of the tangent line is equal to the slope of the secant line. Let's try another problem. So let's say that f of x is equal to x divided by x plus 3 on the closed interval -1 to 3. So is the function continuous in the closed interval from a to b? Since we have a rational function, notice that x cannot equal -3. Otherwise, we will get a 0 in a denominator and it's going to be undefined. But fortunately, -3 is not in this interval. So it is continuous in the closed interval from -1 to 3. Now, is it differentiable? Right now, we don't know. We'll have to find the first derivative and see if it's differentiable on the open interval. So we'll take a look at that later. So let's go ahead and find the first derivative. We need to use the quotient rule. So let's say if it's f over g, the quotient rule is gf prime minus fg prime divided by g squared. So it's going to be g, which is x plus 3. F is x, so f prime is 1, minus f, which is x. G prime, the derivative of x plus 3, that's 1, divided by g squared, which is x plus 3 squared. So x plus 3 times 1 is simply x plus 3 minus x. These two cancel. And so the first derivative is equal to 3 divided by x plus 3 squared. Notice that the function is not differentiable at -3. The derivative is not continuous at that point because it's still undefined at -3. But -3 is not in the interval. So the function is differentiable on the open interval from -1 to 3. So we can use the mean value theorem. So f prime of c, which is going to be the derivative of the function, is equal to f of b minus f of a divided by b minus a. So f of 3, that's 3 over 3 plus 3. F of -1, that's -1 divided by -1 plus 3. And 3 minus -1 is 4. So what can we do to simplify this expression? Three plus 3 is 6. So what we have here is 3 over 6, which is 1/2. -1 plus 3 is 2. So this is -1 over 2. So it's negative minus 1 over 2, all divided by 4. One over 2 minus -1 over 2 is the same as 1 over 2 plus 1 over 2, which is 2 over 2, and that's equal to 1. So at this point, what we need to do is cross multiply. So 3 times 4 is 12, and x plus 3 squared times 1 is simply x plus 3 squared. Now our next step is to take the square root of both sides. So on the right side, we're going to have x plus 3. On the left side, we're going to have plus or minus root 12. Now square root 12, we could simplify it. This is 4 times 3, and the square root of 4 is 2. So it's plus or minus 2 root 3. So x is equal to -3 plus or minus 2 root 3 if we subtract both sides by 3. So we have two answers. -3 plus 2 root 3. The first answer is positive 0.464 as a decimal. Now for the other answer, -3 minus 2 root 3, this is -6.464, which is not in the interval, but positive 0.464 is between -1 and 3. So at this c value, the slope of the tangent line is equal to the slope of the secant line. So this is the answer.